orbit of planet Earth around the Sun causes many things to happen on our planet as a side effect. The Earth's orbit is slightly elliptic and not completely round, meaning that the Earth is closer to the Sun during part of the year. Most people believe that when the Earth is closest to the Sun, it is hotter, causing summer, and colder when it is further away, in winter. This is true for the southern hemisphere, but incorrect for the northern hemisphere. When planet Earth is closest to the Sun, the northern hemisphere is actually in winter. When Earth is most far away from the Sun, the northern hemisphere is in summer. It's true that the Earth's distance from the Sun could make a difference to the weather that we have, but the distance between us and the Sun is not enough to have an impact on our climate. What causes the Earth's season is actually the tilt in Earth's rotational axis. The Earth is tilted between 22 and 24 degrees, and is currently tilted at around 23.5 degrees. At any given time of the year, one hemisphere is pointed a little towards the Sun, which makes the other hemisphere point away. The tilt is caused by the gravitational pull of other planets in our solar system. While the Earth orbits the Sun, the tilted rotational axis causes different parts of the Earth to receive different amounts of the Sun's direct rays. This results in the seasons that we have. While one hemisphere is pointed more towards the Sun, that hemisphere will experience warmer temperatures and longer days, while the other will have colder temperatures and longer nights in contrast. While it is summer south of the equator, the northern hemisphere is in winter. This is the Sun shining directly onto the southern hemisphere, while the northern hemisphere does not receive much direct sunlight. Half a year later, the opposite will occur. The Sun will be shining directly onto the northern hemisphere and indirectly onto the southern hemisphere. What we call spring and autumn are when the Sun shines equally on both southern and northern hemispheres. The rotational axis of the Earth is also directly related to our concepts of day and night. Actually, due to our axial tilt, we have different amounts of daylight. When the Earth points most towards the Sun, we have what we call a summer solstice, the longest day of the year, and when the axis is pointed most away from the Sun, the winter solstice occurs, causing the shortest length of daylight. This is also in sync with the seasons. Summer will have longer days, higher temperatures, winter with cooler temperatures and shorter days. But when the Earth is tilted 90 degrees away from the Sun, every place in the world has about 12 hours of daylight and night. These are called the fall and spring equinoxes. Despite this, the length of day and night are not exactly equal on the dates of the equinox. The days that have about 12 hours of daylight and night each are actually occurring a couple of days before and after the equinox. This is due to the spherical shape of the Earth, as the dates will be different for different latitudes. The change from day to night on Earth is caused by the rotation of Earth's axis, while the tilt of the Earth is what causes the seasons. The length of day and night is actually directly affected by the tilt of our Earth. While the Earth orbits the Sun, the Moon orbits the Earth. The orbit of the Moon is very close to completely circular, tilted at about 5 degrees to Earth's plane of orbit. There are two different types of lunar months, a sidereal lunar month and a synodic lunar month. It takes the Moon around 27.3 days to return to the same place in space. This is called a sidereal period. The other lunar month, called the synodic period, is the time the Moon takes to return to the same place in relation to the positions of the Sun and Earth. The synodic lunar month is directly related to the phases of the Moon. It is the amount of time between successive recurrences of one phase of the Moon, the amount of time between, for example, one full moon and the next full moon. The two lunar months aren't equal due to the fact that the Earth itself orbits around the Sun as well. For example, if we started measuring both lunar months, starting from a full moon, one sidereal month later, the Moon will be back to its original position in the sky, while as seen from Earth, the Moon will not yet be completely round. This is because the Earth has orbited around the Sun during the lunar month, and the Moon has to move a little more around its orbit around the Earth to be seen as a full moon again. This process of catching up to the Earth takes a little over 2 days. Because the synodic month is based on the relative positions of the Sun, Earth, and Moon, and measured by how the Moon is seen from Earth, this is the month that the phases of the Moon depends on. Essentially, the phases of the Moon is the Moon reflecting different amounts of light during different times of the synodic month, not the shadow of the Earth falling onto the Moon. The only time in the whole synodic month where the shadow of the Earth comes close to the Moon is during a full moon, where the Moon is fully illuminated by the Sun, as the Sun, Earth, and Moon are forming a line. This line is not completely straight, which makes it possible for the Earth's shadow to be cast on the Moon. But the shadow of the Earth only falls onto the Moon twice a year, during a lunar eclipse. It will not usually cast a shadow on the Moon, as the Moon moves either above or below the shadow due to the slightly tilted orbit of the Moon. Starting from a new moon, the moon is in between the sun and the earth, so the side of the moon that we are able to see receives no direct sunlight, and is only lit by the sunlight that is reflected up from the earth. About a week later, the moon moves around 90 degrees around the earth along its orbit, and as seen from earth, only half of the moon is seen. This is the moon's first quarter, as the moon is a quarter of its way around its orbit. Between the new moon and the first quarter is a waxing crescent. A waxing crescent is a sliver of the moon on the right side, seen from Earth, that becomes the first full half of the moon. 2 weeks after the occurrence of a new moon, the sun, earth, and moon are aligned in that order. The moon is now fully illuminated by the sun, thus the naming of a full moon. Between the first quarter and the full moon is a phase that we call a waxing gibbous. There is only a sliver of the moon that we cannot see from Earth, on the left side of the moon, as the first quarter becomes a fully illuminated circle. 3 weeks after a new moon, the moon will have moved another quarter of the way around the Earth and around its orbit. This is the third or last quarter of its orbit. The left half of the moon is shown to be illuminated from Earth. Between the full moon and the last quarter is a waning gibbous. It is similar to the waxing gibbous, but a full circle, reducing to a half circle. It is a small amount of the right side of the moon that we cannot see from Earth. Between the last phase of the moon and the last quarter of the moon is a waning crescent. This is the half of the moon reducing until we are unable to see an illuminated part of the moon from Earth. The 4th week after the last new moon and the last week of the lunar month, the moon is back to its original position as seen from Earth. The moon passes between the sun and the Earth, either above or below the sun, and we cannot see any part of it that is illuminated by the sun. Occasionally, the moon will pass right in front of the sun and a solar eclipse occurs. We can only see one phase of the moon, as the moon's orbital period is the same as its rotational period. As the moon moves around the Earth, the side we are able to see becomes more illuminated by direct sunlight. The gravitational forces between Earth and moon also contribute to us being able to see one side of the moon only. These gravitational forces also cause tides. Both the moon and the sun are causes of tides on Earth. The moon's gravitational force causes a pull on the Earth. Due to the Earth not being completely solid, there is a slight pull towards the moon and again on the opposite side. This forms two small bulges on the side closest to the moon and the side directly opposite. Because the Earth rotates once every day, much faster than the moon rotates, this causes the bulges to move around the Earth about once a day, allowing 2 high tides to occur per day. The gravitational pull that causes the bulges are much more effective on water, especially ocean water, thus causing us the tides that we have. There are 2 tides that we discuss in this topic, spring tides and neap tides. Spring tides will occur at a full moon and a new moon, when the sun lines up with the Earth and the moon. The gravitational forces of the sun and the moon occur in the same direction, so the 2 forces add together, creating a stronger tidal force than usual. The extremely high tides that are caused by the stronger tidal forces are named spring tides, as the tides spring higher than normal. A neap tide is what happens when the sun, moon, and Earth forms a right angle. This would be during the first and last quarter phases of the moon. Because the 2 gravitational forces partly cancel each other out, high tides will be lower than usual and low tides will be higher than usual. The forces partly cancel each other out because although the sun's mass is a lot larger than the moon, the larger distance will lessen the force pulling against, therefore causing a similar force to the gravitational pull as the moon. The moon's orbit causes the phases of the moon, causing a synodic month, but it also causes the tides that we have on Earth. The moon's gravitational pull on the Earth causes the tides that we have, as the gravitational force pulls the Earth slightly towards the direction the moon is in, and the direction exactly opposite. Much of what happens on Earth that we see as something that happens naturally is actually caused by what happens outside of the Earth and inside the solar system, or even outside of the solar system.